Hey everyone, welcome to Geometry, Section 2.6, Proving Angles Congruent. All right, so last lesson we talked about proofs a little bit and introduced them and the idea of two-column proofs where on one side you put your statement and then on the other side you put your reason. And your whole goal is to take what they've given you and arrive at the conclusion that they want you to get to. And every step along the way you have to justify how you know you can do that step. So we're going to continue with that. We're going to get away from the algebra so much and get more into the geometry aspect of it. So before we do that, let's talk about what you need to know to do by the end of this lesson. You need to know how to use the linear pair and vertical angles theorems to find missing values in a diagram. You also need to begin to understand and formulate proofs using a variety of definitions, postulates, and theorems. So that's just basically, can you do a proof and use the definitions, postulates, and theorems that I gave to you on that reference sheet in order to justify each step. So just do a quick review of some of the more commonly used theorems and postulates. There's the angle addition postulate, which we've talked about before, which says if you've got two angles right next to each other, this little angle plus this little angle adds up to be the big angle. So if you see a diagram very similar to this where you have two angles right next to each other, it's not uncommon to use the angle addition postulate, depending on what they're asking us to do. The linear pair theorem. If you recall, a linear pair looks like this, where you've got two adjacent angles that together make up a straight line. As soon as you know that this is a straight line, you can say, yes, these two are a linear pair, which also means that the two angles add up to 180. They're supplementary. Supplementary. One of those two. Potato, potato. And another very common theorem that we use is the vertical angles theorem, where the vertical angles are directly across from each other. So the two purple angles are vertical. The two teal angles are also vertical. And a key thing with that is as soon as you see a situation like this where there's vertical angles, you can automatically say this angle is congruent to this angle because of vertical angles. Okay? Very common things that we can do. So to use linear pair and vertical angle theorems in an example like this, I want to show you how to set up an equation and solve for different angles. So here the directions say find the value of x. So what I can do on number 15 is I can say that because those two angles form a linear pair, again, they're two adjacent angles that make up a straight line, I know that they add up to 180. So I can say 2x plus 52 equals 180. And then I can solve that equation. Let's subtract the 52 and divide by 2, and I get x equals 64. Now it's quite possible that they could say find the measure of each angle, in which case I could just take that 64 and plug it in, and I would get that this angle is 128. Let's do another example real quick. Number 16 is the exact same type of problem, so I'm not going to do that. Let's take a look at number 17. Here we have the example of vertical angles. So two angles directly across from each other. So you should know that vertical angles are congruent. So the equation I would set up here is 4x plus 48. Nope, that's not right. It would be 4x equals 48. Kind of went on autopilot there. So 4x equals 48. That's my equation. And then we just go ahead and solve it by dividing by 4. X equals 12. Now, just for fun, let's go ahead and do question number 18. These two angles are not equal to each other, nor do they equal 180. But my clue here is because I've got that little red box, that tells me that that's a right angle. So this angle plus that angle have to add up to 90. So 39 plus 2x plus 1 equals 90. Combine the 39 and the 1 to make 2x plus 40. Subtract the 40 and divide by 2. And there you go. X equals 25. So that's an important thing to know, is just if they give you a diagram, can you use vertical angles or linear pair to solve for x? Or if they ask you to, plug that number back in and solve for the angle. So now let's get to proofs, all right? All right, so for the rest of this lesson, we're just going to go through and do a couple examples of proofs. This could be tedious, this could be boring, and I understand that. So I encourage you, take lots of breaks, watch one proof, and then take a break, go do something else, let that simmer in your mind a little bit. Maybe come back, watch it again, watch other examples. But do not just watch this and kind of be checked out, playing on your cell phone while you're doing something. This is important stuff, and it's very tricky. So the more diligent you are about how you study it, the better. So here we have a 2-column proof. And on one side, we put the statements that we're going to make in order to go from this statement. If AC is the same length as BD, then AB has to be the same length as CD. Okay, we're going to go from this given statement and work our way logically to come to the conclusion that AB has to be the same amount as CD. So first thing I'm going to do is I'm going to go ahead and mark up the diagram. So AC, going from A all the way to C, is going to be the same length as going from B all the way to D. Okay, so that information was given to us. So on our first statement, how do I know that AC is equal to BD? Because that was given to us. And 99% of the time, the very first statement that we do in a proof is just take what was given to us and state it. Okay? So statement 1 should almost always be given. Now statement 2 says AC equals AB plus BC. So AC, this longer segment, is made up of AB plus BC. So what's that called when we have one segment made up of 2 smaller segments? Or the way we learned it, the more familiar, is this little segment plus this little segment equals the big segment. That's the segment addition postulate. Now, I'm all for shorthand, so rather than write the segment addition postulate, if you were to write SAP, that would be fine. If you write SAP, I think everyone knows what you're talking about. Okay, now they made a second statement, BD is made up of BC and CD. They're just saying that this second long segment BD is also made up of BC plus CD. Again, that's the same reason, the segment addition postulate. So you can have more than one statement, and as long as they have the same reason, you can put those 2 statements in the same step. All right, now take a look at what we've got going on here. Here they say AB plus BC is equal to CB plus CD. Okay, so what they did here was they said, okay, since AC is the exact same thing as AB plus BC, let me go ahead and highlight that. And what they said was, because AB plus BC is the same thing as AC, how about I plug it into that equation? And then they said, since BD is the same thing as BC plus CD, what if I took that and plugged it into that equation, that part of the equation? And so I come up with this new equation. And hopefully highlighting it makes it easy to see that they took this, the AB plus BC, plugged it in there. Took the BC plus CD, plugged it in there, and came up with a new equation. So when you take something that's just as good as another thing and you plug it into an equation, that's what we call substitution. So that's my reasoning for this one, is the substitution property. So now if we take a look at this, here I have AB plus BC equals CB plus CD, I notice that I've got BC on both sides of the equation. So, could I subtract BC from both sides and get those out of there? Sure. And then I'm left with the conclusion that we're coming up with, which is AB equals CD. So my reason for that is subtraction. Now you probably just watched that whole thing and be, whoa, what the heck just happened? That's okay. I get that. This is complicated stuff, and I don't expect you to pick up on every single thing right from the beginning. All right? It takes a lot of time, practice, and it really helps if you have this reference sheet that I gave you, so you can take a look at all the different properties and definitions and stuff that we can use. But yeah, this is very much a skill. It's less of a mathematical process and more of an art. And so the more you do it, the more you'll get better at it. Let's try another example. So it says given angle 1 is the same as angle 2, and angle 3 is the same as angle 4. So I'm going to go ahead and mark this up. So 1 is the same as 2. I'm a visual guy. I like to go ahead and mark up the diagram so I can see what's going on. And angle 3 is the same as angle 4. Okay, so that's the information that's given to us. What we're trying to figure out now is prove that angle ABC is congruent to angle DEF. So what they're trying to get us to prove is that this whole big angle is the same as this whole big angle over here. So they've gone ahead and given us the steps. All we have to do is provide reasoning for how do we know that that's true. So step 1. Angle 1 is the same as angle 2, angle 3 is the same as 4. How do we know that? That was given to us. So we just put given. All right, so step 2, they say the measure of angle 1 plus measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. So the way that they were able to get that is they took this original equation, angle 1 equals angle 2, and then they added angle 3 to the left-hand side and angle 4 to the right-hand side, because if you have two things that are equal, you can add them to both sides. Okay, so that is the addition property. So then step 3, the measure of angle 1 plus the measure of angle 3 equals ABC. Well, if we take a look at our diagram here, angle 1 plus angle 3 equals that whole big angle. That is our angle addition postulate. If I've got two angles right next to each other, they make up the big angle. And again, if you want to take the shortcut and call it AAP, I'm fine with that. Now this other statement right here, angle 2 plus angle 4 equals angle DEF. There we go. All right, so yeah, this little pink angle plus the little green angle equals the whole big blue angle. Yeah, that's still the same thing, angle addition postulate. All right, so last step, how do we arrive at this conclusion that the measure of angle ABC is the same as the measure of angle DEF? Well, take a look back at step 2. All right, in step 2, on one side of the equation, they have angle 1 plus angle 3. And then right here, they tell you that the measure of angle 1 plus the measure of angle 3 equals the measure of angle ABC. So what they did was they went back to this equation in step 2, and they took out angle 1 plus angle 3 and replaced it with angle ABC. And then, still going back to this equation in step 2, they took this part, the measure of angle 2 plus the measure of angle 4, and said, well, if the measure of angle 2 plus the measure of angle 4 is the same as angle DEF, I can take out angle 2 and angle 4 and put in DEF in its place. And there we go. I arrived at this conclusion. Angle ABC is the same as angle DEF. And because I took something out and put something just as good in its place, that's the substitution property. Okay, again, this was a complicated proof to go through. I don't expect you to pick it up right away. If you can just pick up one or two things out of this entire proof, and then we'll just do more and more examples, and the more you do it, the better you're going to get at it. Okay? So if you're lost, if you're freaking out because you don't understand this, I get it. Okay? This is not an easy topic at all. Let's try this one. So given angle 2 is the same as angle 3, prove that angle 1 is the same as angle 4. So let's go ahead and take a look at our steps here. Angle 1 is congruent to angle 2. You know what? Before I even do that, let me go ahead and mark up the picture. So it tells us that 2 is the same as 3. So that's what was given to us. And they want us to prove that 1 is the same as 4. Hopefully this will be an easier proof and something that you'll be like, okay, I get that. So build up a little confidence here. So angle 1 is congruent to angle 2. Step 1, how do I know that 1 and 2 are the same? Well, I'd say that they're the same because they are vertical angles. And again, if you want to abbreviate it like that, vert-ang, I'm cool with that. Step 2. Angle 2 is the same as angle 3. How do I know that? Well, that was given to us. So most of the time, our first step is the given statement. It doesn't always have to be. If there's something obvious like vertical angles from the diagram, you can go ahead and say, you can start there. All right? Step 3, angles 3 and angle 4 are the same. Again, I think that's a little bit of vertical angles. And then how do we use that to say that 1 and 4 are the same? Well, if we take a look at all the statements we have here, 1 is the same as 2. 2 is the same as 3. 3 is the same as 4. So do you remember the transitive property that says if A is the same as B and B is the same as C, then A and C have to be the same? That's exactly what we have going on here. So that's what I'm going to put here is the transitive property. And so we've gotten to the conclusion that they want us to come to, that angle 1 is congruent to angle 4, and we've justified every step. Let's skip that one. Okay, let's go ahead and try this one. Given, angles 1 and 2 are supplementary. So let's go ahead and mark those up. So angle 1 and angle 2 are supplementary. Now, because they're not the exact same, I'm not going to put a single arc here and a single arc there. I put a single arc here and a double arc to indicate that I don't know that they're the same. Okay? I'm just highlighting them. Okay, so we know that those add up to 180. Prove that 3 and 4 are supplementary. Okay? So let's go ahead and go through our proof. Now, in this case, they didn't give us the statements, they gave us the reasons. So we have to come up with the statements. And at the beginning, that's what it's going to be. It's going to be a structured proof where you fill in the gaps as opposed to you coming up with both things on your own. All right? So step 1, given. So angle 1 is congruent to angle 2. Well, I don't have an angle button on here, so I'm just going to say angle 1. All right, did I say congruent? I meant they're supplementary. Okay? So if angles 1 and angle 2 are supplementary, what does that mean? Well, it means that they add up to 180. Okay? And that's the definition of supplementary angles. It means that they add up to 180. So I will put angle 1 plus angle 2 equals 180. All right. So step 3, it says vertical angles are congruent. So they want us to find some vertical angles in here. So I see 2 and 4 are vertical angles. So you know what? I'm not going to type anymore. I'm just going to go ahead and write this in. So I can say that angle 2 is congruent to angle 4 because they're congruent, or because they're vertical angles. I can also say that angle 1 is congruent to angle 3 because of vertical angles. Now take a look at this next reason, definition of congruent angles. This is going to be a tricky one, and I'm going to give a lot of leeway on this. But notice how step 2 is an equation. Angle 1 plus angle 2 equals 180. And notice in step 3, I've got congruent signs. Well, I can't really mix stuff if one thing has congruent signs and one thing has equal signs. So what I have to do is I have to get it so that they're matching. Either everything has to have congruent signs or everything has to have equal signs. And again, I'm going to be fairly lenient on this because this is just a fine detail. But what I'm going to put here is if angle 2 is congruent to angle 4, that means that they have the same measure. So I'm going to put angle 2 equals angle 4. Or if I wanted to be real precise, I'd put the measure of angle 2 equals the measure of angle 4. And then I'd also put the measure of angle 1 equals the measure of angle 3. Now, why would I do that? Because if I go back to this equation here in step 2, angle 1 plus angle 2 equals 180, and I'm trying to prove that 3 and 4 are supplementary, what I can do is, since I know that angle 1 equals angle 3, I'm going to take angle 1 out of here, and I'm going to put angle 3. Let me go ahead and highlight that just to... Can I highlight that? Okay, well, not going to highlight it. So what I'm saying is, I had angle 1 right here, and I know angle 3 is just as good as angle 1, so I put angle 3 in where angle 1 was. And here where I have angle 2, I know that angle 4 is just as good as angle 2, so I'm going to go ahead and put that in there. And then bring down the equals 180. And the reason I know to do that is because of substitution. If I take something out and put something just as good in, substitution property. So now I've got angle 3 plus angle 4 equals 180. Well, that's what I'm trying to prove, right? Is that angles 3 and 4 are supplementary. All right. Well, it's like I'm this close to it. Here I'm saying that angle 3 and angle 4 equal 180. So what I need to write is exactly what it says. Angle 3 and angle 4 and the reason that is because that's the definition of supplementary angles, is that they add up to 180. Here, let me get my head out of the way so you can see what's going on there. Now, again, I'm covering a lot of material, so I don't expect you guys to get this all at once. And the more time we have in class, the more time we're going to spend doing examples, and hopefully you guys can get some idea of how to do this. All right, but we're going to take baby steps at first, and hopefully you guys will ask questions, and I can help fill in the blanks for you guys. So I think that's all we're going to do for today is just do those proofs, and again, we'll do lots more once we get in class. So hopefully this wasn't too bad. Actually, I know this was bad. This lesson is very, very tough. And you're probably scratching your head saying, oh my gosh, I don't understand a thing. That's all right. We'll get there. Okay? So if you have any questions, please feel free to email me. Please ask questions in class, and we'll get this proof thing tackled. All right? Hope you guys have a good one. Bye.